In this video, I want to look at a variation on a straight line question that tends to throw a lot of students off. So the most common straight line question is when you're given 2 points on a line and you've got to work out the gradient and then the equation of the line. And most students are okay with that question. A more tricky question can be if you're given the equation of the line and you're asked some questions about that line. And the things you'll be asked are, what are the gradient or the y-intercept or even the x-intercept where the line crosses the x-axis. So if the line is in the correct format, which this one is and this one's not, then you can just read off the gradient and the y-intercept because that's the m value, that's the c value. They just are the gradient and the y-intercept, so you can just read them off. There's no work to do there. So given this line here, we can just say by looking at the line that the gradient, which is the coefficient of the x term in the correct format, the gradient is just equal to 2. So a no-brainer, just reading that off. Similarly, the y-intercept is 8. Just remember that's only the y-coordinate of the y-intercept. So in general, usually you will need to include the other coordinate because they'll say what is the coordinate, and the full coordinate is going to be 0, 8. Okay, so just by reading off that straight line equation, which is in the correct format, we can see that the gradient is 2 and the y-intercept is 8. But the thing that's not in the formula is the x-intercept. We need to find that. But let's just consider what we've got so far for our line. So if I was to go ahead and make a little sketch here, the y-intercept is at 8, so that's going to be positive 8, which is up there somewhere. The gradient is positive 2, so a positive 2 gradient goes sort of this way. So it's going to be something like that, meaning that the x-intercept is somewhere over here. So it's that x-intercept point we're now trying to focus on. But just like the root points on a parabola, if you're a point on the x-axis, you have got a y-coordinate of 0. So any point along the x-axis has got no height, like no vertical height, or it's nothing up the way or down the way. So this has definitely got a y-coordinate of 0. So it's a no-brainer that we can say that the y-coordinate of that point is going to be 0. So we can use that information to find the x-intercept just by substituting that 0 into the equation. So if we go back to our original equation, which is y equals 2x plus 8, substitute in the 0 for y. As soon as we do that, we've made it into essentially a little equation to solve to get the x value. So if we just solve that equation, we would get 2x equals negative 8, x equals negative 4. And you can see that sort of fits into the diagram, because if that point there was 8 up the way, that could be 4 to the left, 4 back the way. So that's how we find the x-intercept. Similarly, actually, that's how you find the y-intercept, because the y-intercept point has definitely got an x-coordinate of 0. If you put a 0 in there for x, you would get y equals 2 times 0 plus 8, which is just 8. So this is only the y-intercept purely by the fact that if you let the x be 0, it's going to take out the x term. That's why that n number is always the y-intercept. But that's in the case where the line is in the correct format. This line is not in the correct format. So let's say we're dealing with the same 3 questions, gradient, y-intercept, and x-intercept, for this particular line. Well, the x-intercept and the y-intercept work the same way, because if you're on the x-axis, your y-coordinate is 0, and if you're on the y-axis, your x-coordinate is 0. So we don't really need to adjust the formula to get those values. If we did rearrange the formula into this format, the n number would be the y-intercept. But you don't have to do that. You could do that, but you don't have to. So if we just say, for example, that if we're trying to find the y-intercept, we can just say that we're going to let the x be 0. So taking our equation, that's going to be 4 times 0 plus 3y equals 12. That's going to be just 3y equals 12, and then y equals 4. So that tells us that our y-intercept is at 0, 4. So there was no rearranging involved there. Similarly, if we wanted to get the x-intercept, we're just going to do the opposite. We're going to let the y be 0. And these are the same principles you would use for finding the y-intercept or the root points on a parabola graph. If you're the x-intercept, if you're on the x-axis, your y value is 0. So we're putting a 0 in for y this time. So that would be 4x plus 3 times 0 equals 12. So that's just going to be 4x equals 12, given x equals 3. So then we can say that our x-intercept is going to be 3, 0. What about the gradient? Well, the gradient you can't, one thing you could do is to use these 2 points now to get the gradient. But generally you're going to get the gradient by rearranging the line. So just by doing a bit of algebra. So we want to make y the subject of the formula. So we can achieve that by subtracting the 4x to the other side. So we're going to get minus 4x plus 12. Almost there at that point, but you need to get it all the way to y, so dividing by 3. So y equals minus 4 over 3x plus 12 divided by 3, which is 4. And then we can see that the gradient is that number there, which is minus 4 over 3. So generally for gradient, you do need to get the line in the correct format unless you've got 2 points on your line. But for the x and the y-intercept, it doesn't matter which version of the formula you use. You're just subbing in the appropriate 0. Notice, by the way, that after I rearranged that, the y-intercept came out to be 4, and we'd already found it to be 4 by this algebraic method. So all these methods should be consistent. But the key takeaway here is that if you're a point on the y-axis, your x-coordinate is definitely 0, and you can use that. And if you're a point on the x-axis, your y-coordinate is 0, and you can use that to find the other corresponding coordinate.